Hello, in this video I'm going to show you how to calculate the altitude of a geostationary satellite. Let's start by calculating the rate of rotation of the Earth. So the Earth rotates one round, so that's 2 pi, in every 1 day. So that's 24 hours times 60 minutes times 60 seconds. So the rate of rotation of the Earth turns out to be 7.27 times 10 to the power of negative 5 radians per second. Let's return to the satellite. Since the satellite is doing a circular motion, surely it requires a centripetal force that's pointing towards the center of the Earth. And that force is provided by the Earth's gravitational pull on the satellite. So, applying Newton's second law on the satellite, we have the gravitational pull written as gm over r square, providing the required centripetal force written as mr omega square. Now, for a satellite to be geostationary, its angular velocity must match the rate of rotation of the Earth. So it must also make one revolution every 1 day. So the omega of the satellite must also be 7.27 times 10 to the power of negative 5 radians per second. We now sub in all the numbers. Once again, the little m is irrelevant. So we have the universal constant of gravitation, we have the mass of the Earth, and see, for the omega, I've written it as 7.27 times 10 to the power of negative 5. Use your calculator. R turns out to be 42,235 kilometers. But this distance is the radius of the circular motion, which is this distance here. What we want is the altitude. So the altitude is going to be 42,000 kilometers minus away the radius of the Earth, giving us about 36,000 kilometers. Yep, it's a pretty long distance away. But if you want to be geostationary, you have to put your satellite that far away. That's all. Ta-ta!